Thank you, everybody. So my name is Tamas Jos. The talk of my title is Spooky Authentication as a Distance. This is obviously a reference to the Einstein's theory of portals. First, we are going to talk about today's sponsor, which is Raid Shadow, which is SecConsult besides Troopers. As you know, I am working at a company called SecConsult as a security consultant there. And SecConsult is really, it's well known on German-speaking regions mostly and parts of Asia. We are doing penetration testing, red teaming, and other IT security consultancy services. Please hire us. And inside of SecConsult, we have a vulnerability lab. And we are churning out a lot of O days and one days to some of the clients that you can, or unwanted clients that you can see here. Next to SecConsult, basically I live a double life, so to say, as probably many of you in the audience as well. Besides my day job, I also have a night job, and this night job is Scene Change, Porchetta Industries. I'm a member of. This is kind of like a freelance, like a free alliance of hackers of various skills. And this talk is mainly from the research that I did before and during when I was part of Porchetta Industries. More about them later down the line at the end. So in my nightlife, I'm an open source developer. So at first, whatever I'm going to present is going to be open sourced, or it's already mostly open source. Pull requests and issues are more than welcome. I will probably ignore most of them for a year, and then I will get back to you with additional questions. Sorry about that, by the way, whoever submitted to something for my project. I'm a creator of many security projects. Most famous one is probably PyPyCats. I don't know how many of the audience have used PyPyCats, have heard of PyPyCats. I hope you are having a great time with it. It was a really fun project to write. But next to PyPyCats, I also like to implement or re-implement from scratch various protocols, ranging from really, really complex to not really complex protocols. And this talk is going to be focusing on authentication protocols and the relation of these networking protocols. So I have implemented the Kerberos protocol, ldap protocol, SMB protocol, SSH protocol, and an RDP protocol from scratch. Everything is open source, free to use it. I'm mainly working in Python 3, and all of my projects are using the async.io framework. So, what is this talk going to be about? So the promise is that in this talk, I'm going to show you a novel technique that basically allows you, it's a novel post-exploitation technique that allows you to, after dropping a single agent on the victim side, you will be able remotely to perform authentications over major Windows protocols, so ldap, SMB, RDP, whatnot, to any servers inside of the victim's domain without elevated privileges and without any prior information of the domain. So everything is going to be happening as if you're executing the SMB client on your own attacker machine, then this SMB client is going to work as if it would have been executed as the victim on the victim machine. But with the major caveat that, not caveat, major positive side, that it does not require you to push any additional code on the victim machine. This means that if the first stage is like the agent itself is not being detected, then you are reducing the detection surface considerably on the long run. So like the only way that like you might be detected is by monitoring the network traffic, because like it's going to occur higher network traffic, but more on that later. So the outline of the talk, we are going to talk about Windows authentication protocols, just a brief generic summary on like how authentication protocols work. We are going to take LDAP as an example. You are going to see so many protocol ladders. I don't really know like the proper technical terms, but you will soon see what I'm talking about. And then there is going to be a brief introduction to SSPI, and then there's going to be demo. I prepared 2 separate demos for you. One is a pre-recorded demo that shows that the attack actually works, and there is one live demo in which I'm going to show like prepared embedded system. It's basically like a Raspberry Pi. And this Raspberry Pi, hopefully, if it works, and like I tried it like many times now, so I hope that it's going to work, it is going to work as basically an automated penetration testing toolkit. If you plug it into an unlocked Windows workstation, like domain-enrolled Windows workstation, it's going to start automatically pawning the domain without you having to do basically anything else besides plugging in the pen drive. So, Windows authentication protocols in a nutshell. Protocol ladders. So how in most discussions that I have with generic pen testers, when we are discussing authentication protocols in general, they are either thinking about authentication protocols as in, well, basically I'm just sending like the username and password to the server, or the server like hashes the password and checks it in the database or whatever. That is like the dumb one. Like the more like more eloquent ones, they are involving some kind of like challenge response protocol, like NTLM, for example. So like the password is never going through the wire for obvious reasons, because it's not 1980s anymore. But still, like even the ones that are I don't know, like on a medium level in terms of pen testing, if we can say that, the discussion usually stops when the authentication succeeded. So now we are in. And this is like not really a good way to seeing it, because like authentication protocols nowadays, they are providing more features than just like, you know, like establishing who the user is and whether they have like authorization, depending on the protocol, of course. Whether they have authorization to the server, but also they are providing you with a shared secret, and usually in normal protocol, like everything after the authentication goes encrypted, and not necessarily encrypted with an SSL TLS channel, but encrypted with the shared secret or derived keys from the shared secret that are generated during the authentication steps. And this is like a really important distinctions that we would need to make right off the bat. So here, what you're seeing is that, I just wish I can make it this a bit bigger. Sorry about that, technical problems. Yes, oh, much better. So in general, like till the protocol initialization is completed, how does it work? So let's say that we have a client and a server. Client can be, I don't know, let's say that it's like an ldap client. We are going to be focusing on ldap because like it's a really good like example of a protocol that went through multiple iterations for authentication protocol support. So in the client, we have some like basic protocol, basic version negotiations that usually involves the like what type of authentication methods the server supports, what kind of authentication method the client supports, and then they pick one. Then if depending on the authentication protocol, you have a negotiation inside of the authentication protocol. This is going to be like this information or this distinction, like this transmission of traffic is already like wrapped inside on top of the existing protocol layer, like for example over LDAP. we are selecting an authentication protocol, and then we initialize the authentication client and the authentication server. Obviously, this is just a generalization. It's much more complicated, especially on the server side, because usually, like in a Windows server, obviously not every Windows server has everybody's credentials when authenticating, but it is just for a generic overview. So like when we get it initialized, then the authentication message, like the protocol-specific authentication messages, are basically wrapping the authentication data that is originating from the authentication client or from the authentication server. This data is being passed back and forth till we arrive either the user could authenticate or could not authenticate. In this case, we can authenticate. And at the end of the day, we are going to have a shared secret, which is the same on both sides, and possibly with an initialization vector, depending on the authentication protocol again. So at this point, protocol initialization is complete. Congratulations, you are logged in. What are you going to do next? You probably would like to, I don't know, get the shares, like get the list of available shares on an SMB protocol. So there is a user interaction where the user like requests to list down the shares. This is going to be translated on the SMB protocol level, that's like as a request, but this request is not going to be, and this is plain text, so this is not going to be passed directly to the server. First, it's going to dispatch it to the authentication context. Sorry, I wanted to say LDAP because SMB is a bit different. We are going to get to that part later. But first, the message is going to be dispatched to the authentication protocol, which already have an encryption-decryption context created from the shared secret. It's going to be wrapping this message. Wrapping means, like in this case, like encrypting this message. And then it is going to be wrapped in an encrypted message wrapper. So already we are like wrapping it 2 times. We're sending it back to the server. Server says, oh, this is an encrypted message, so I need to dispatch the message buffer to the authentication server. The authentication, like encryption-decryption context, is going to yield back the plaintext bytes, which are going to be reparsed by the server, and it's going to be processed. And then this goes on for like turtles all the way down. This goes on forever. So, word from the author, which is me. Hi, everyone. We are going to discuss the ldap protocol in the future examples because, as I said, it's a really good example. So, ldap supports multiple authentication methods. Who in the audience knows what Sicily authentication method is in ldap? Yeah, so Sicily was the first step for Microsoft to basically, in their journey to I would say like rape other protocols to force NTLM onto them. Probably like a better example would be like HTTP, which was completely destroyed for the sake of supporting NTLM. But ldap is no different. Like usually you don't find Sicily unless you are using my implementations. Because it's considered outdated. This is basically a raw NTLM authentication. ldap protocol was not implemented back at the time to support multi-step authentication processes. So when this got introduced, so basically they were, even right now, if you check in Wireshark, when there is like Sicily authentication going on, the dissector is going to say that's like, yeah, something is happening here. I'm not really now. I'm not fully sure what at some point in time. Anyhow, so. In ldap, usually you can do like a cldap query without any authorization to any ldap server, especially like in Windows networks. This is consider this as the version negotiation, so you can get some basic information like what is the domain name, what OIDs are supported for which type of methods, and then Sicily authentication is going to come. Sicily authentication is going to be wrapped in a bind request. And then the server is going to reply with OK. In normal cases, bind request OK means that, OK, you're authenticated. Not in this case, because, again, this is something that was forced onto ldap. So this just means that, OK, now I can initialize my NTLM client and perform like the NTLM authentication. So we have like NTLM negotiate and the continue that says that's like, okay, we can continue. I have some more data if well, sorry. like it is like the continue flag is going to signal this like yes, like we can. I'm still open to receive other messages. Not really the point. So it's going like the negotiate structure is going to be wrapped in a bind request. Is going to be sent to the server. Server passes it to the NTLM server on the other side. NTLM server is going to come back with the NTLM challenge, and then NTLM challenge is going to be wrapped to bind response. Like you get the drill. And at the end of the day, if you see that like there is no encryption decryption part happening here, why is that? Because in order to like NTLM itself provides encryption decryption functionalities. It is happening with RC4 encryption. That is like the key itself is going to be derived from the shared secret. However, in terms of LDAP, you would need to like specifically tell to the server that like I would like to have encryption following the authentication, and this is like usually not the case, and it is definitely not the case when LDAP-S is used, because it is in the Microsoft standards that like if you're using LDAP-S, so like LDAP over SSL/TLS, then you are not allowed to use encryption, like any other encryption underneath. I have no idea, like if somebody can like mail me the reason, I would be interested to know, because I really like network protocols. I don't know if I could make it more obvious to the audience. So then introducing espinago. Espinago is an authentication protocol. Espinago authentication protocol is basically not providing authentication itself, is like an authentication protocol selector protocol that supports NTLM, Kerberos, and other versions of Kerberos. But like in theory, like it could support like any kind of authentication, but like it's only used by Microsoft, or it was implemented by Microsoft. So we are basically just discussing Kerberos and NTLM. And this allows like an additional layer besides the protocol, not the authentication protocol, but the actual like protocol LDAP or SMB, to further discuss what they would like to, like which authentication protocol is going to be the final authentication protocol. Now, yeah, we are not done with this one yet. One interesting thing espinago provides, which is like not strictly like the point of this talk, is that if, let's say that you have a hacked client, like something that I wrote, for example, and you immediately go to the server and says that, hey, I want to do NTLM, not the Sicily one, but the NTLM over espinago, then the server is going to send you one extra packet after the authentication has finished. And this extra packet contains basically a signed list of the protocols that the client, e.g. me, have sent to the server when deciding which authentication method to use, because they suspect that somebody was actually like taking out Kerberos from the espinago negotiation. And with this signing or signature method, they would be able to detect, because the attacker would not be having the session key at the end. They would be like in an NTLM relay attack, for example, or in the man-in-the-middle case. But because it's signed, like the server expects the client to do the same stuff and sign the requested protocol methods and send it back to the server, and only then can be the authentication fully considered valid. Otherwise, like the server is not going to release the session key. Actually, it's going to terminate the connections. Now, where is espinago introduced in LDAP? So LDAP supports the following authentication methods. So like you have the simple authentication. Yeah, it's the 1990s. We are sending username and password in plain text on the channel. Sometimes we even like performing bind without any information at all, because we are a one big family in this subnet. So like there is no need to care about security. Then Sicily was implemented, which is raw NTLM, and then LDAP said it's like, okay, like we really see that you would like to do this like challenge response, like actual like authentication protocols, so we are going to introduce the SASL or SASL. I'm just going to call it SASL. And SASL is a protocol selector for other authentication methods. And then we have like the SASL. Inside of it, we can use external, which is like really interesting if you're doing penetration testing and you have some certificates already available to you. The external one basically says, I'm not going to send you like any authentication material. I already authenticated with MTLS, like with a certificate to you. So consider that my authentication. And this can do some, like with this, you can do some bypasses if you manage to obtain a certificate and a private key for some other user for like ESC, like certify attacks, sorry, ADCS attacks. And if it's configured incorrectly, like, or not incorrectly, that is not true, like incorrectly to the attacker's perspective, so like that. Configured it in a way that like you are not able to use it to, I don't know, directly authenticate to SMB or whatever. Using this method, you can still bypass this irregularities and, for example, like get an LDAP connection as a domain administrator, and then it's pretty much game over at that point. Anyhow, moving on. So we have espinago, which underneath the espinago you are supporting NTLM and Kerberos, and then we have GSS API. This is like kind of like espinago. Linux users probably use it more often than I do, and many others. But just for one weird reason, I felt the need to include Digest MD5 here, because, yeah, historical reasons. Now for the big one. I wanted to explain like how like an NTLM authentication over espinago over SASL authentication in LDAP looks like. It's fun. Sorry, I don't want to bore the audience with this one. I'm including this one because to get you a better understanding further down the line how the attack that I'm going to present will actually look like, and how much hoops I needed to go through to get to that point where it's like working reliably. I'm not going to read out everything because the logic is the same that I explained already. It's just like with multiple extra hoops here. Just a second. This was good. Homework for the audience, if you like them, you can analyze this chart. For Kerberos authentication, sorry? I think I heard something, whatever. So for Kerberos authentication, again, LDAP, SASL, espinago, Kerberos authentication, usually it's simpler because like the Kerberos client it's not shown in the graph, like in this letter. The Kerberos client will just like receive the ticket and just going to pass it to the server, and then basically like you're in, like you don't need to do this challenge response stuff. It can be more complicated when we are using mutual authentication. This is going to come up later. Anyhow, so we have discussed LDAP authentication. Now we are going to discuss a bit about SMB. The thing is with SMB that, going back here, sorry. So like in LDAP, after protocol initialization is completed, like you either have encryption, and this encryption is supported by either NTLM or Kerberos. They have their own encryption ways, and it depends on like multiple factors. Don't want to get into that one. But SMB's major distinction factor is that the encryption-decryption context is going to be handled by the SMB protocol itself. They do not rely on the encryption-decryption methodologies that are implemented in Kerberos and LDAP. How does it work? So like after protocol initialization has completed, you have the shared secret, and basically the SMB client just like yoinks the shared secret out of the authentication context and then builds its own encryption-decryption methods. So we had the generic overview. Now I would like to talk about today's target. Today's target is the security support provider interface called SPI. And this SSPI is basically like a set of Windows APIs, Windows functions that you can invoke. It is there because I don't know, it might come as a surprise to the audience that Alsys is caching your credentials, maybe. And but Alsys does not want to release the plaintext credentials to you, or the already processed anti-hash, for example, to you. Yet, in Windows environments, after you log in, you usually don't need to retype the password every single time when you are performing an authentication. That would be extremely annoying when you have a corporate proxy and that requires authentication for every single new HTTP request, right? Yet you would need to create Microsoft needed to create a way that basically we are caching it, but also we are not releasing it. So the way that the logic that they followed is the same kind of logic that you would find in a smart card. Is the keys on the smart card. What you can do with these keys is that you can ask the smart card to perform to start certain authentication methods, and just gives you back the result or the first step, or in case of a multiple step authentication process, right? So SSPI is there for that one. With SSPI, you can trigger an authentication. It supports Kerberos, NTLM, CredSSP, espinago. What was this certificate one? It supports a plethora of authentication methods, and the core premise is that it's not releasing the key, unless, of course, if it would support an authentication method that it would easily allow you to recover the key, right? Like NTLM v1, for example, that is something that you would be able to crack back, and this is why we are trying to, or Microsoft is trying to kill at least NTLM v1 with fire, but in the future, probably NTLM is going to be future. In 50 years, when we figure out space travel and whatnot, whatever. So SSPI, these are not it relies on these 5 API calls. There are much more API calls, but if you implement these 5 API calls, then you can actually write an application that performs then an authentication, whatever. You would need to bring your own protocol as well, but that's besides the point. So acquire credentials handle is going to basically initiate, it will be giving you a context, an authentication context, that you can use to then call initialize security context over and over. So if we go back to this part, every single time there is the get out data, NTLM negotiate, NTLM challenge, NTLM authenticate structures are going to be passed via this initialize security context call. And when the authentication has finished, then it means that now the shared secret is available in SSPI. And a generalization, so again, same kind of protocol ladder. First we do acquire credential handles, then initialize security context, in and out. Okay, in and out. And then finally, we have a shared secret available. And then, with the shared secret, again, it is not going to give us the shared secret unless we ask it nicely. This is going to be later down the line. We have the encrypt message and decrypt message that is belonging to the authentication context that has been established by the acquired credentials handle. And with this one, we can just basically do the encryption and decryption. So we don't have to. You don't have to implement any type of encryption if you are implementing a protocol. Yes. So, but if you want to implement your own SMB client, right? Who doesn't want to implement SMB at home? Apparently there are some people, but whatever. You want your proprietary SMB client to be able to leverage these API calls. Because you would like to make it compatible with Windows. And, but you are going to have a problem, and the problem is that SMB has its own like encryption-decryption context. So you would need to have the initialization vector and the key somehow, like the shared secret somehow. Otherwise, like you will not be able to use the encrypt-decrypt functions in the SSPI process. So I faced this problem, obviously, and there is, I don't know if it's visible, but there is a specific function which I mentioned earlier. This is the query context attribute, which you can invoke after the context is or like the authentication process already finished. So you have the context handle, and then it can give you the session key. So you can just like request it nicely, and then it's going to release the session key for you. This is something that is both like documented and not really documented. At first, since I did not know about it, it was a bit hard to navigate Microsoft documentation to find it, and finally I found it in some Rust implementation because it's basically just one flag. But then now I knew what to call it, and then searching the documentation again, it was at some point in the MSDN documentation. Anyhow, but we have a problem. The problem is like yet another problem. I have like a lot of problems. So the other problem is that like in order to get the to recreate the encryption-decryption context in a mutual authentication, like we would need to have the initialization vector. This is only a problem in mutual authentication in Kerberos because in non-mutual, so like normal Kerberos authentication, the initialization vector is going to be included in the ticket, and since you get the session key, you will be able to obtain the IV from the ticket itself. However, in mutual authentication, what is happening is that there is like an extra round of back and forth, and the initialization vector is being sent encrypted back to the LSAS, like back to via SSPI, and it is encrypted with a key that LSAS does not release to you. And this is a problem because mutual authentication is kind of required when, for example, you want to do a DC sync, right? So, and you would like to support DC sync with Kerberos in an attack method. So the problem was that's like, hey, like there is no API call to release the initialization vector key. How would it be possible to actually obtain the initialization vector? And I had a hard time finding it out, but then I was basically like, if I just invoke encrypt message, the encrypt message like in a correct way, but with some gibberish data, then it's going to be yielding like a wrapped token, like with an encrypted data inside, but like the initialization vector needs to be like plain text or like public, because like on the other end they would need to decrypt it. And then you can unwrap this token and get the initialization vector out. So now you can rebuild the entire authentication context. And why is it needed? Now we are getting to the attacking part. So your LSAS, but on my machine. So let's imagine a system where basically what you're doing is that you're creating like a custom RPC wrapper for the aforementioned function calls, and you deploy like you create a protocol that allows the attacker to create authentication contexts on the client side, ad hoc authentication contexts on the client side. With this one, you would be able to implement your own clients on your own attacking machine that, when instructed, would be leveraging these API calls remotely for every session created. And that would mean that now you can basically like impersonate the user itself. But this would require you to have an appropriate client that is capable of leveraging this type of protocol, and also the authentication method would need to be implemented that can rebuild the encryption-decryption context at the end. And yeah, this is what I did. So let's see how it looks like. I promise you this is going to be just 2 more slides with the letters, okay? And this is going to be completely unreadable. So this is what my software does, actually. So what is happening is that the red lines are a SOX proxy related thing. So like SOX proxy It's included in the agent. You don't really have to deal with it. Everybody knows that. The blue line, the green lines itself are the SSPI proxy related things. So in a generic logic, we create a TCP connection via the. Now, let me just explain to you how the framework looks like. So you are the attacker. You are green. You sit at home because you like to work from home. And somebody in a corporate domain environment, we call him or her a victim, double-clicked on an executable or opened the docx that you sent to them via email. And this basically triggered this agent, the SSPI Proxy agent, to start. SSPI Proxy agent is going to allow you to perform, going to give you a SOX proxying possibility and an SSPI proxy possibility. With the SOX proxy, now you can take, from home, you can, via the team server, but it's not included in the graph, you can basically say this hey, I would like to go to the domain controller and authenticate to the domain controller as the victim user. The TCP session is via SOX proxy. Initial steps is via the protocol implementation. And then when we kick in the authentication method, the client's, the attacker side library, protocol implementation, is going to reach out to the client, to the target side authentication proxy, and this is going to trigger an RPC call, which first is going to invoke acquire credentials handle, like all the jizz that I just explained regarding a normal SSPI flow. And at the end of the day, what you're going to end up with, the authentication, is that on the client, on the attacker side, you will be having an SMB client that now you can use to authenticate to any server in the corporate domain environment without knowing the password of the user and without having without requiring administrative privileges or any other type of exploits delivered by mail to the victim. So one more thing, and then we are going to go with the demo. There is a wrong way and a right way of doing. After the authentication, we need to deal with the encryption decryption. This is the wrong way. This is the wrong way because in this case, we are basically invoking 3 extra calls for each and every message on the protocol that we are supporting, and we are dispatching it back to the victim to have the victim else's process decrypting this protocol. What we can, and this is completely inefficient in bandwidth terms, what we can do instead is by leveraging the fact that we can obtain the session key for each and every authentication context, you would need to do that, and by invoking encrypt message one time only, and that yields the initialization vector, you can basically yoink the encryption decryption context from the remote machine to your own machine, and now you can leverage this encryption decryption context indefinitely for that specific connection. So all this thing that you see here and here, it needs to be done every single time when there is a new connect, then you are initiating a new connection from your attacker computer. So how does this look like in real life? It kind of looks like this. So we have the domain user and CrowdStrike watching the milkshake, which I'm drinking from home. Basically, I have a really, really huge straw. Now for the demo. Is it? Oh, it's visible. Okay, so demo setup explanation. On the top slide, you are going to see the attacker. On the bottom side, you are seeing the victim. And basically, they are currently in the same network. But still, SOX proxy is going to be demonstrated as well. So how do we look like? We are at that specific IP address. On the victim side, we are specifying this huge long as in all my tools, you will need to deal with this one. Sorry, sorry about that. Maybe I will add some configuration files so you don't have to each and every time type out this whole command, but it allows you to precisely set what you want to do, what you want the protocol to be doing, where and how. And this is like much more. I find this method much better than the other like publicly available software. But it's just like, yeah. So what we are seeing here is we are going to show a who am I all. We are not administrator. We don't have like special privileges and whatnot. And then we are basically going to execute this this agent binary and this. Come on, man. Whatever. Like, it's not that important what is written there, but it's basically just for that it's for demo purposes only. And then we are going to execute the SMB client, and basically we have a login. And our SMB client did not, basically it wasn't provided with any secret credentials and whatnot. And here in the messages, we'll see that, okay, login success, awesome. And I created debug, like a debug log just specifically for this talk, so you can see that basically like every single time that this SMB needs like a next step of the authentication, that like this is the data that is being passed back and forth between the protocol and the client. So we have an SPN, we have the negotiate. The negotiate is actually coming from the SSPI part on the victim machine, and is being fed back to our SMB client. And then we basically, yep, you know how like NTLM works probably. So like I don't want to take more time. And then finally, like after the authentication, we are going to fetch the session key. As you can see, that there is no fetching initialization vector there because this is NTLM and the initialization vector is 0. And yeah, so and then we can list the shares and we can basically like use shares and I don't know, like I think we are downloading the NTDS.dit. And this is not downloading it from the victim machine. This is downloading from the domain controller via the victim machine in the victim's context. And yeah, that is it for SMB. And then, thank you. And I have a demo for ldap as well. Like ldap, this is going to be with Kerberos this time. And yeah, it was that fast. We are already there. So sorry for the like a lot of debug messages. It's yep. And here we are grabbing the Kerberos table users list from the domain controller basically. So everything works as expected. We can do a who am I, and we can see that like we are proxying it via the victim. So we are basically impersonating the victim machine as the result of the who am I command. And yes, that is it for the first demo. Do I have something? Yeah, just for fun. Like you can do certify and other stuff as well. So like it's basically like a fully working. There are no limitations to what you can do after the after the authentication process completes. Okay, so we have this one. And before, oops, sorry about that. Okay, so we have this one, and then before I'm showing you the other demo, I would like to finish with the slides, and then if we still have time, then I'm going to show you the live demo. So going back here, okay, and going back here, okay, awesome. So what is the current status of SSPI Proxy? Basically, it sadly currently requires like a custom, like the agent obviously is going to be custom because like I don't know any other tool that would implement such logic right now. The libraries, however, is already they also need to be custom because of like I started integrating it with my Python projects, but more on that in the next slide. Hopefully there's going to be a huge surprise. So yeah, the library is called WSNet. This is like this is what implements the SSPI proxy right now. Everything is going to be Everything is going to be published under MIT license on the Python side. On the agent side, it's going to be published, but like later on because of other conference obligations. So like, really sorry about that. Also, like the Auth library is the authentication library. Like if you have your own protocol that you would like to leverage in like protocol implementation that you would like to leverage this logic right now, then you can use the Auth library, and then it's going to take you this far that I showed in the demo. And yeah, like all of my tools are using Auth, but like probably it comes no surprise. So a bit of a comparison of like using this technique versus the already like existing techniques. I have a few benefits and a few drawbacks. Main benefits are going to be that like again, like no exploits, no high integrity, no additional code is needed to be deployed besides the first agent, and then you can leverage the victim context for basically like all major protocols or whatever other protocols that you might implement. I don't know, like you could use the same technique for MS SQL integrated authentication as well. But this one is not, like that one is not implemented. You will have to implement it yourself and send me a pull request. Yeah, one other thing is that like you can drive the SOC insane with this. You can, like you are not limited. If you remember the demo, there was like a huge long-ass command line parameters because like you needed to specify both the authentication proxy and the SOC proxy as well. They don't need to be the same. So if you infect multiple machines, then you can basically switch like from which user context you would like to connect to which server via which server, and it makes like detection quite hard for the SOC, which is always fun in my opinion. Some of the drawbacks is that, yeah, as of right now, this is a custom protocol, like implementations are needed. They are available, but like you might not be familiar with Python because you like to use Go, Rust, whatever. I hope that even for you, this presentation is going to be valuable because then like you can just take this, like it's kind of that simple to implement the client-side part in whatever language. On the other part is going to be simpler. I'm going to show it in the next slide why. And yeah, compared to traditional C2 solutions, like since you're working from home, like you need to have like a constant network connection. So like this is going to be like much more bandwidth intensive than than you know, just like deploying a code, waiting for the result, and then channel back only the result via your C2 framework. Now, for the future. So this talk is going to be presented on DEF CON as well with some additional slides, and then when the talk is presented there, I'm going to publish the agent so everybody can use it. And I have some other big plans for this project, more on that later. Also, a really interesting stuff, so there is this ethical chaos guy. Hi, if you see this presentation, big fan. He created a tool called LSA Relay X, and this LSA Relay X was created originally to basically like facilitate NTLM relays, by basically like hooking the low-level functions that are inside of LSAS to basically like hook NTLM. One could extend this to hook Kerberos as well, and you can relatively easily interface it with this new technique. It doesn't have to be my implementation, it could be your implementation as well. This would allow you to basically not rely on my custom protocols. I will be a bit sad, but I would fully understand if you want to use your own tools, because this one, like if you manage to get this working, then any Windows application that you're executing with this hooked LSAS will now be able to leverage SPI Proxy. Like that includes like a full-blown MS SQL client, for example. You don't need to basically do anything. You just say that like, I would like to authenticate to a server, and so on and so forth. So yeah, I would encourage my audience to look into this. The possibilities are there. So like it's a good challenge too, and fun to write. And one last stuff, I don't know if Durkan is in the room. So this, the SPI Proxy functionality can be extended. Same, like not the same, but like another set of API calls that are using Windows Certificate Store can be proxied relatively easy. This is on my roadmap to allow Kerberos PKeyInit and other type of certificate-based authentication protocols to be leveraged, including like this would basically work on Windows Hello for Business, and other Azure-related stuff. So, and this is, well, yeah, this is for making Durkan happy, and also myself a little. So, as the last slide, so. Thank you for everybody who helped me. Most of the people here, they haven't necessarily helped me directly, but with the open source tools that they are providing, like I'm a big fan of open source tooling. So Ethical Chaos with the LSA Relay X. At first, when I saw his project, I was like, oh my god, like he implemented my technique that I haven't published yet, because that was I was close to having a heart attack. Bori and Jordan for the SMB protocol and the Python GSS API, really valuable. Awake Coding, who is not a hacker, as it turns out, like he just asks questions that a hacker would ask when like he is really into RDP protocol implementations. I'm pretty sure the dude would make an awesome pen tester for SSPIers, and of course the Impact team for the Impact team in general, but specifically for Axolino, because I had a chat with him like 5 years ago, which triggered this whole like flurry of protocol implementations, because I wanted to move away from Impact. So thank you very much. I don't know if we are going to have like, do we want to do the QA or do we want to see the live demo? I would go with the QA, and I can show the live demo like personally later on down the line, but I don't know what the audience would like, because it would probably take more than 5 minutes. We have more than 5 minutes. Okay, great. So then immediately switching this one here and duplicating the displays. Okay, keep changes. So what you're seeing here in front of you is like my machine, but this is like set up specifically for this demo. This is now a domain enrolled machine. The domain controller is it's in a VM. But like this is how everything can be shown from a single laptop. And I have this pen drive here. It's actually a Raspberry Pi with like USB OTG. This pen drive is, when I plug it in, it's going to basically eat itself way up and enumerate the domain and try to do some exploitation, like well-known, like logical bugs, like CertiPy, and enumerating the nodes as Bloodhound would do, but like with Pi implementation, without any additional user interaction needed besides plugging this one in. And this one, the way that it works is that like it has like a rubber ducky feature to execute the initial agent, but also it emulates a USB network device. It has a DHCP server. The DHCP server is going to, like, network device is going to be detected on this laptop. It's going to like receive an IP address via the DHCP server that is inside of this. And this one also contains a service to which the SPI Proxy implementation that is going to be executed via the rubber ducky script is going to connect back. And that one is fully scripted in a way that it would attack basically any domain controller, not just this one, because of SPI Proxy does not need any additional contextual information about the domain environment that it is in. This means that this is like a generic PWN-all tool for basically any domains. So if I plug it in, fingers crossed, hoppa. Yeah, who brought this chair? Sorry about that. It will take roughly a minute or so to. It's not a fast device. Yeah, I'm working on it, making it a bit faster, but we'll see. Look, Ma, no hands. Okay, and we should be seeing 2 lines soon. Okay, there we go. So what is happening here is that we have already connected back to our C2 server that is running inside of this Raspberry Pi, and the domain enumeration is going to start soon. It basically automatically, yep. Now we are enumerating the domain on the backend. You don't have to believe me. You don't have to believe me. I will show you what is happening there. If I can. Hey, where's my browser? Oh, cool. Thank you. Okay, some technical. Oh, Jesus. Thank you. So this is the IP address of the Raspberry device, and there is a tool called Octopon. If you have seen my previous presentation about like pen testing from the browser, this is it. It's just like propped up a bit. So what we are going to do is that like we are going to connect as an operator to this device, and this is how it looks like currently. Like this is like real-time data, what is happening on inside of the device. And we are currently using Jackdaw, which is like my Bloodhound implementation, to enumerate the domain. Here in the credentials tab, we basically have one credential with no actual credential in it. It's just like a reference to the proxy, the SPI Proxy agent that connected back. Here we can see the server. This is the agent part. And the agent is basically like this is the agent, like the actual program that we executed automatically on the device. What we can do here is that, for example, like we can maybe take this. It will take a bit probably. We'll see. No, okay. So we just Kerberosted basically the entire domain with all the users just with this press of a button. The data inside of this domain is generated via bedblood. It's a script that just like throws like random data inside of the domain controller. But it generates like pretty things that we can see. And also downstairs here, like we can, it's going to be a bit slow because of the Raspberry Pi is currently like chewing up the domain data. It will take roughly 3 more minutes, based on my previous experience, to actually see the Bloodhound-like graph that we extracted from this domain controller. I don't really wish to touch the screen while we are doing this, because then it might time out. However, this is what we are going to see, and then we are going to see the graph. Since it's like 5 minutes, I'm ready to take questions now, and then we will after the Q&A part, we can come back and see what we finished.
All right, so are there any questions from the audience?
Where can I buy this product?
Yeah.
Is this for sale?
It is on this version is on Porchet Industries private repo, but like the Octopon itself is not something that I'm showing here because like I'm trying to sell you this product or anything. It's just like, since everything is already integrated, I can show you like a live demo of how it works. But like if you support us on Porchet Industries, there is going to be a version available for Octopon as well. So like you will be able to build this thing yourself.
Right. Any more questions? maybe one from my side then. I'm here.
Okay. Hi.
So yeah, you showed that you basically only use legitimate SPI API calls and
Yes.
basically behave like a legitimate program. So what would you, as the author, say would be the easiest way to like detect it in a deterministic way? So.
Don't run programs on your machine. No, I mean like there could be like multiple ways to detect it. Sorry, just okay. We are still generating, but like it will arrive soon. So like one of the ways is that like you can like monitor the traffic itself. So like it's going to be spiking up because of the SOX proxy and the what I explained earlier. Also, it is like I do not know how many applications, like legit applications, are requesting the session key from an authentication context. I legitimately do not know because I haven't seen like I haven't implemented any other like I haven't implemented legit applications in general. So I cannot really comment on that. But like I would probably check if like somebody is calling that specific API, then it might be something, but like I did not really look into the detection possibilities into it. Any other questions?
No, thank you. That was
okay, great. So we have finished. So we have enumerated the domain, and these are the paths to the domain administrators that you can see here. I can probably like zoom in or zoom in a bit. Yeah. So we have domain admins, domain admin members, some OUs and whatnot. And again, this is like all happening. I should have brought a mouse. This is all happening without any information. So I just plugged it in the USB stick, and you have all this data. So feel free to like run around with USB sticks and connect it to unlocked workstations. Any other questions? No? Then thank you very much. I hope that it was valuable for everybody.